Educational Module, Statistics for Data Science, Learning Unit, Core, are variables and operators. Getting help in RStudio. In the introduction course you were introduced to the work environment of RStudio. Before moving on to discussing general R syntax and variable types and definitions, it is important to know how to access RStudio Help. R has an inbuilt help facility similar to the man facility of Unix. To get more information on any specific named function, for example solve, the command is help solve. An alternative is $solve for a feature specified by special characters. The argument must be enclosed in double or single quotes, making it a character string. This is also necessary for a few words with syntactic meaning including if, for and function. Help. Either form of quote mark may be used to escape the other, as in the string that's important. Our convention is to use double quote marks for preference. On most R installations help is available in HTML format by running help.start. Here you can see an example for executing help.start in RStudio. Note that on the bottom right section the Help tab is brought to the foreground. On this tab you can search by topic or using the search box. General syntax in R. Commands are separated either by a semicolon or by a new line. Elementary commands can be grouped together into one compound expression by curly braces. If a command is not complete at the end of a line, R will give a different prompt, by default plus on second and subsequent lines, and continue to read input until the command is syntactically complete. Comments can be put anywhere, starting with a hash mark $. Everything to the end of the line is a comment. Note that you cannot put comments inside strings, nor within the argument list of a function definition. Technically R is an expression language with a very simple syntax. It is case-sensitive as are most Unix-based packages, so A and A are different symbols and would refer to different variables. The set of symbols which can be used in R names depends on the operating system and country within which R is being run, technically on the locale in use. Normally all alphanumeric symbols are allowed plus full stop and underscore, with the restriction that a name must start with a full stop or a letter, and if it starts with a full stop, the second character must not be a digit. Names are unlimited in length. Object names cannot start with a digit and cannot contain certain other characters such as a comma or a space. It is a good idea to adopt one of the widely used conventions for naming your objects in a meaningful way, like the ones used in the examples below. I use snake case, but you may use periods as well, or even use camel case. Elementary commands consist of either expressions or assignments. If an expression is given as a command, it is evaluated, printed unless specifically made invisible, and the value is lost. An assignment also evaluates an expression and passes the value to a variable, but the result is not automatically printed. In the screenshot below you can see how to define a variable, inspect its value in environment tag, print its value on the console, and evaluate an expression. Note that after executing the assignment to X, the value of X is displayed along with X in the environment tag in the upper right pane. But to see the value of X on the console we must ask for it either by typing the name of the variable or with the print X command. To see a list of all objects created so far you can use function ls. The collection of objects currently stored is called the workspace. Each variable takes some place in the computer memory. If you work on a big project, it's good to clean up your workspace. To remove a variable, use the function rm. In the example on the right you see that we assign height the value 10, and width the value 5. Then, we assign area with the product of height multiplied with width, and to see the value of area we call function print area. After inspecting the result, and if we will not be needing the height and width variables any longer, we can remove it from our workspace by executing rm height, width. There are 5 main types of operators: arithmetic operators, arithmetic functions, assignment, relational and logical operators. Below you can see a listing of each category operators in tabular form. Arithmetic operators include regular operators for addition, subtraction, multiplication, division, exponentiation and modulo. Once you define variables, the data analysis process can usually be described as a series of functions applied to the data. There includes several predefined functions, called arithmetic functions. These functions include logarithms, exponential, as well as trigonometric functions, absolute value and square root. Assignment operators are used to assign values to variables. We have four alternatives for assignment operators and you see them in this table. Relational operators define the relation between two entities. For example, less than, greater than, less or equal to, not equal, etc. Logical operators. These operators compare the two entities and are typically used with Boolean logical values such as and, or and not. Special operators are used for specific purposes, not for logical computation. For example, operator colon creates the series of numbers in sequence for a vector, while operator %in% is used to check if an element belongs to a vector. In the screenshot below you can see examples using assignment, relational and special operators. Note the usage of alternative assignment operators and their results in the environment tag on the right. Also see the use of colon for generating a sequence of numbers from 2 to 8. And the check for whether string card is included in the string my series. Packages are collections of R functions, data, and compiled code in a well-defined format. The directory where packages are stored is called the library. R comes with a standard set of packages already available, but you can install additional packages to expand the types of analyses you can do. A complete list of contributed packages is available from CRAN at https://cran.rproject.org/web/packages/. You can also download packages from other repositories, such as Bioconductor and GitHub repositories. On Windows, to install the package from CRAN you should 1. Choose Install Package S from the Packages menu. 2. Select the CRAN mirror, for instance Greece or Bulgaria. 3. Select the package, for instance ggplot2. 4. Then use the library package function to load it for use. For instance, library glop2. Steps 1 to 3 are only executed once on your computer and you only have to load the already installed package in each R session you need it. Note: for other repositories the process is different and you should look for specific instructions per case. You can view the list of the already installed packages on your computer by typing installed.packages. It's a good idea to save your workspace image when your work sessions are long. This can be done at any time using the function save.image. This way you can store your workspace to a file named .data by default and be sure that you will not lose all your work in the event of system reboot. For instance, when you close R/RStudio, it asks if you want to save your workspace. If you say yes, the next time you start R that workspace will be loaded. That saved file will be named .data as well. It's also possible to specify the file name for saving your workspace by executing save.image file equals my_work_space.data. To restore your workspace, type load my_work_space.data. In this unit we discussed how to access R help, which is the general syntax of R, how we define variables in R and which are the main operators we can use. In addition, we saw how to install packages and how to save our workspace so we can retrieve it in future sessions.